And that's
Wow.
JSON parsing with higher order types using parser combinators.
Wow. I feel like my life is a lie. Like I've been living a lie. It's like you're in a time travel movie and you find out that there was a universe where you like hit the lottery. It feels very enlightening, but also I don't have a time machine. So just a little warning, this video is not for the faint of heart. This is about an hour and a half of the most advanced possible TypeScript. And if you're wondering why push TypeScript to its limits like this, what's the point? Consider that there doesn't necessarily always need to be a point. This is about challenging your thinking, exploring new perspectives, and giving your brain a good workout. All that stuff is something that you can bring to your day job and make use of in a very practical sense. So this is about as cutting edge as it gets in the TypeScript world today. We hope you appreciate the time and effort we put into making this. And if you do like it, get excited because we have showcases coming on the channel soon for hkt-toolbelt, which is Mike's library that we use in this video, as well as another library that's similar, hotscript. Hot is higher order types and hkt is higher kind of types, and they're kind of like two names for the same thing. So anyway, JSON parsing. Hope you enjoy. Okay, welcome everyone. This is JSON parse. The last video was like extremely long, so we thought it would be better to just split this up. This is its own solution. It kind of does stand on its own. It's different than, it doesn't follow the same conventions as many of the type challenges because it uses this library you see on the screen here, hkt-toolbelt. And we'll talk about it soon on the channel, but we haven't talked yet about who Mike is and what he does, really. And Mike is the author of hkt-toolbelt. What is HKT, anyway?
Yes. So HKT stands for higher kind of types. You can also say higher order types. And what these are, in a nutshell, is the ability to take in generics in TypeScript without passing in their value. So you can like take in unprocessed generics, so to speak, so you can map over them, filter them, reduce them, compose them in arbitrary ways to create like very powerful sort of composable type utilities.
Can we talk just about the simplest of simple ones? Can we just talk about filter num on the README?
Yeah. So,
okay.
Yeah.
What is the situation you would need something like this, or would want? Maybe nobody needs anything. We could all be hermits, but why would you want something like this?
So you would really want something like this when you have an example. You have a series of types, maybe somewhat complicated types. They all have a similar element to them in a way that you would want to maybe implement dry, right? Like you don't want to repeat yourself, but you find yourself unable to write a abstraction to sort of elide kind of an abstract, explanation, but really it's to avoid repeating yourself and to write more complicated things in a very in a simpler way, such that you don't need to implement map every time. Like every time we want to do a filter, or every time we want to do a map, we have to rewrite the implementation of filter or map in every utility we do. What this library allows is we don't need to rewrite it every time.
So like in this situation with filter num, like we're passing in filter, but like as a function almost. And then we're passing in as the second thing, we're saying, hey, make sure that the things that we're going to be filtering in the future extend number.
Yeah. So what this does is so we can see in the type result section below, evaluating filter num on this tuple of 1, x, 2, y, and 3, we get 1, 2, 3 at the end. So if we want to create a filter string now, all we have to do is copy the implementation of filter num, and then instead of passing a number, pass in string, right? And then what we could as well do, right, even higher abstraction, is we could say, oh, let's parameterize filter num and make filter num take in any type, and then we're building like a type that builds a filter based on
filter
the type
primitive or something. Yeah,
filter primitive, exactly. So we are able to reuse these things. In prior universe, we had to like copy and paste a bunch of stuff. now we can fully like create our types in a fully like don't repeat yourself manner.
Got it. Okay, I think okay. So I have switched over now to the code editor. Sorry. I think I understand where this is going. So our goal for today is to build a JSON parser with this sort of library, I suppose. Mike pre-prepared this, so we're going to go through it. Mike you'll lead the way. I'll probably just sit around and with my amazement. To anybody who hasn't seen this is a sort of continuation of a video that Mike and I also did as part of the TypeScript type challenges. You could think of this as part 2, where we looked at 4 different solutions for solving this in TypeScript type system. And the problem itself is, just to get it out of the way, we're making a JSON parser. And, JSON has very few rules. It is a context-free grammar, and there's, a lot of opportunities to implement something like this in TypeScript's type system. Of course, TypeScript is Turing complete. I hate when people say that, because it's not actually Turing complete, because the recursion limit is like a 3-digit number. So it's like, yeah, you can't like implement, the Linux kernel in TypeScript's type system, because you're going to hit a recursion limit like immediately. Anyway, our goal is to make a parser that will take in a string. This is just a string, which is JSON. And then when parsed, will return an actual TypeScript object with the literals and with the string values parsed out and everything. So with that, Mike, I hand you the mic. Okay, sorry.
Indeed.
Have I ever,
yeah. So let's scroll down and let's immediately kind of look at the let's actually start from the bottom up. So let's start with the simplest possible thing. Let's start with null.
Oh, okay.
Yeah.
Tell me a line. Okay, yeah. Where should I head?
Let's head to line 78.
Okay. There we go.
So we're going to start at the bottom, and then we're going to create a successively more complicated structure. So, what we're doing here is we are parsing a string into a Boolean value. So, to sort of show the result of this, as you do in hkt-toolbelt, we're going to use the dollar input, and then I'm going to say input is true and result is never. This is a parser state, but if we hover over result now, we get result is true. So if input is false, we get, result is false.
Yep.
Hopefully that makes sense, and we can kind of grab the result so it's a little bit clearer.
Mm-hmm.
And then if it's anything else, if it's foobar, we get never.
Never.
So the idea with parser combinators, so first of all, we're using a parser combinator framework built into hkt-toolbelt. That's on line 85. That's kind of what we're seeing here.
That's the $ guy?
$ guy is like how we apply utilities on the library. But so when we see parser2.literal, we're passing in a union true or false. So what parser2.literal is it takes in a string and it parses literally that string and only that string. Then what we're doing with map...
Wait.
Sure.
Sorry. I'm going to be stopping you a lot. I can tell already.
Yeah.
So it takes in a string. What do you mean it takes in? Okay, so parser2.literal. What is parser2, by the way? Why are we saying parser2?
So parser2 is just like the second instance of the parser to avoid breaking changes. It's like a different...
Okay. Just the thing about the library. Okay, doesn't matter.
Yeah. So parser2 is a set of like different parser combinators.
Okay, so literal T is what?
Literal T, or so we can look at like my parser. So literal T is a parser which will only I'll make this even simpler. So my parser is a parser that only parses the string foobar, right? So now if I hover over results and I pass in, my parser, thank you. I get foobar as the result. You wonder, okay, maybe this, and if I pass in like bar, I get never. So very simple. Maybe this is worthless so far, right? But what I can do now is I can make a more complicated type. So I can say, let's say I want to parse, let's say I want to have a sequence of parsers. So I'll say parser2.sequence, and then I'll pass in a array of parsers. So what this will do is, let's format this a little bit.
Yeah, why is there a comma here? Oh, because it's like, okay, can I make sorry.
Yeah, feel free to format this however you think it's most readable. Okay. So what we get at the end is still foobar, right? But now I can say, I can pass in more parsers, and I can say, a space, and then I'll say, hello. So now if I do, foobar hello, what I get for the result is foobar space hello. I could replace this with like parser2 dot utility dot optional whitespace, for example, which is just 0 or more whitespace characters. So now I can say an arbitrary amount of spaces, and I just extract that arbitrary amount of spaces. So this is a way to like compose parsers on the type level and create more complicated ones.
Okay, so my question is like, what happens if this gets something it doesn't like? If it gets foofbar, then we get never. Okay, so the whole thing will crash.
This parser will crash. Yes,
this parser will crash.
Yes, but there are, so for example, there's a parser2 dot instead of sequence, we can say choice. So now what we're saying is optional whitespace doesn't really make sense here. Now we're saying we will parse foobar or we will parse hello. So I can say foobar and it will parse foobar, or I can say hello and it will parse hello. And the neat thing is here, I can like make a sequence of choices, or I can make, choice that contains sequences. So I can say, for example,
wait, stop. So that's because choice T. Okay, so if we had changed this to sequence, then my parser would be equal to sequence T. Oh, okay, so you can mix and match sequences and choices, and even, can you nest them?
Yes, you can nest them. So that's where the power comes in. So I'm going to say sequence, and then this is going to be an array, and then I'm going to say parser2.literal, foo, right? And then literal bar.
Oh, so if we put foobar here, then we get back foo comma bar, because that's that's the first thing that matched to the choice, and that's this. But if we do foofbar, then we get hello. No, why do we get
never?
Why not? Because hello was there.
Well, yeah. So it's saying we either match foobar or hello. So what we actually want is like this, right?
Oh,
yeah. So you can arbitrarily nest these, and I can reference other parsers inside of this. What I haven't quite been able to do yet is to directly reference. So my parser is itself a parser, so I should be able to do something like this. But the TypeScript system really doesn't like that for a reason that I haven't been able to like understand yet.
Tuple type arguments circularly reference themselves.
Have you seen that error before?
Never.
There's a lot of interesting things that happen when you start exploring this frontier.
Okay. All right. I think that's
so
a good.
Yeah.
I think we should keep going with Boolean. I have more questions, but maybe like let's do Boolean because there's more than Boolean to show.
Yes.
I think I get. Okay, so we can delete this. I think I get it.
Yeah.
So generally, okay, Boolean parser is saying, hey, well, what is parser2.map? What's map compared to sequence and choice?
So map is actually has nothing to do with lists really. What it does is it's a monad, first of all. It says whatever we end up parsing as the result, I am going to transform the result of that if it was successful. So what we're doing here is we're saying, I am transforming the result of this like true or false, which is, the string true or the string false, into this like line 78, like we're just checking if it's like true or false. So map takes in two parameters, so to speak. It takes in a parser and then it takes in a function to transform the result.
Which is this parse Boolean?
Exactly, yes. So
why is parse Boolean
is more like,
how could parse Boolean be outside of map? Like I would expect it to be like in here or something.
Oh, because map is being partially applied. So what we're doing is
wow, this is so cool.
Yeah. I don't know. Like,
but this is like my colleagues will hate me kind of cool.
Yeah, definitely.
Okay. I'm glad you're comfortable with that reality.
Yes. So what we're doing is essentially we're taking parser.map. Okay. We're passing in the parser that we want to transform the result of, and then we are passing in the Boolean transformer. So that's Boolean, right? So null is
we didn't talk about the interface here, but like, can you tell me?
I can briefly explain.
Well, how about this? You tell me which one would be easiest to talk about it with.
I mean, we can briefly talk about this. So, okay. This is actually just a pretty simple thing where all we're saying is
we're
taking in.
No, stop it.
It's not simple. None of this is simple.
Okay.
It's very, very complicated. We're taking in a string and we are converting that to true or false. It's written as a kind. An alternative approach to this actually, so I'll say parse Boolean 2 would have been I'm going to import one more module from this called conditional.
Okay.
And I'm going to make an if statement. So I'm going to say if, right? So the if takes in three parameters, so to speak. And I'll do my best to format it nicely for you. So okay, where are we? Okay, so everything's currently good. Okay.
I'm trying to see if I can get, okay, I wanted to get to / while we're talking. Okay.
Okay, nice. So the first thing that if takes in is a predicate, which is a function of the form. It returns a Boolean, right? So the function I'm going to pass in is, does the thing we're taking in equal the string true, right? So that is a predicate because it will return a Boolean. And then the next thing that we pass into if is, which is partially applied, so I need to pass in the next parameter. This is going to be a constant function. So that's going to be function.constant. And the constant that I'm going to return is...
function is from your library, right? You just imported it?
Yeah, I just imported it, yeah.
Okay.
And then the last thing that parse boolean 2 takes in is what happens if it's falsy, which is I'm going to return false. So
where did we check that it's a Boolean at all?
We don't check if it's a Boolean. We just check if it's equal to true on line 86. So parse boolean 2 takes in any type, and if it equals the type string true, then we return true. Otherwise, we return false.
Okay, and this passes all the tests.
Yeah, it is equivalent in behavior to line 78 and 82.
Okay.
So it's a way to create. So we've created a generic without actually creating a generic, without actually having like a angular bracket parameter, right?
Okay. So this interface parse boolean is saying, how come it says it's not used? Of course it's used. Oh, because it's this thing that's used? Wait, where is parse boolean used in the solution?
It's not, because I just replaced it with parse boolean 1. Or where did boolean go? Did we remove it?
Oh, I'm sorry. I must have, we must have deleted too many things. Let me like, okay, I will grab it. I have it all in a thing here.
I think we're good now.
Well, we need Boolean parser.
We have
parse Boolean. Oh, we do have it. Oh, because that's what this is. Oh, okay. Because we rewrote it. I'm sorry.
Yeah, Boolean parser. This is badly named because it's like parse Boolean versus Boolean parser, right? But anyway, so all we're saying is, so now we can remove these two essentially because we've rewritten it to be more like. I think we.
Yeah. I was playing with the name while you did that.
Oh yeah. We've rewritten it to be like more native to the hkt-toolbelt library, in that previously I was writing a custom kind, as I call them, or custom higher order types, which utilize the actual like internals of the library.
All right, let's look at null, and I'll try to. Okay, I'm gonna have like four attempts at understanding the syntax. So like, let's try null, and we'll see if I. So null is the same. It's looking for literal and ull. Those characters in that sequence. Map is partially applied with parse null. Parse null is an interface.
Indeed.
An interface that has an F. So that F thing must be a convention.
Yep.
For like apply. Why did you pick F?
F is just a function, yeah.
Okay. Because there's like K combinator. Okay. Anyway. X doesn't matter, so that's why it's X. It could be anything here. It would make no difference, right? Yeah.
Yeah. We would just need to change it on the right-hand side as well.
Okay. Yeah, fair enough. Okay. So then we have a argument to this function. Type is from your library.
Yep.
_ $cast. So what's going on with this?
So we're saying that parse null has to take in a string. So for example, I can run parse null because parse null is what I call a kind. So I can do this, right? And then results, I'll get our double slash in here. As soon as I find.
Oh man, I do the same. This is so gratifying. I do the same. I just like
one
day I'll memorize which one of those goes where. Okay.
Yeah. So this is never right, but if it's null, then it'll actually translate it into null. So what this is doing is if I pass in something that isn't a string, like 1, 2, 3, then I actually get a compile error saying number is not assignable to string. So that cast is just a way to tell the type system, hey, it extends this.
Whereas if I had done this.
Oh, it's definitely not going to work.
Wait, but why do all the tests pass? Okay, anyway, that's a different question. But why?
Yeah. The tests don't seem to pass.
Oh, really? Okay, maybe I just need to like.
It takes a little bit of time.
Oh,
Let's see.
No, bro, they pass. I don't know.
They pass.
So what is? I
then,
mean, I'll take you at your word. I'm just saying, like, what is the? Let me try to get it back. Okay. Well, anyway, underscore parse this thing underscore dollar parse null is being passed the type of X, which we've already said has to be a string. Okay, so this song and dance here on the beginning of line 108 is to make the compile error appear earlier.
Yeah, like just like when you're passing it in. Yeah, exactly.
When you're passing it in, rather than rather than returning null or never, and then like who knows why it's a never.
Exactly.
Great. Okay, and then this is the actual. So I don't really need this. This is just a like nice little helper.
Exactly. Yeah. Okay. You don't actually need it. You could just.
Okay, and then we're returning the TypeScript value null.
Yep.
And then never. But this never case could never be hit.
Indeed.
So why not just put null here?
Let's see if.
Because it might be a string, but just doesn't extend. Just actually is not the string null.
Yeah.
Okay. All right. That makes sense.
Yeah.
Sorry. Okay. Asking the dumb questions, but that's okay.
No, these are great. Okay.
All right. That's null.
Yeah.
Okay.
So then next is kind of complicated. Escaped character map. So we're enumerating all of the escaped characters that we want to handle as part of the JSON specification, including, backslashes
and double quotes.
Yeah. So first of all, like this type on line 127, we're just keying into that map. No big deal. On line 130, we're just creating a kind to represent that type level operation so that we can compose it. And then for escaped characters is the interesting one. So all we're saying is this parser, first of all, parser2.literal, we're passing in key of escaped character map. So we're saying it will parse any of these keys as a literal, and then it will map that result into parse escaped character. So if I run it, I pass in, // then technically I need to pass in an entire input.
Input
and then get the result out. And it doesn't work because that is not an escape.
Yeah, I was going to say you have to double.
Yeah.
Okay.
Yeah. Or if we pass in, this, it will just, pass in. It'll just parse any escape character, and it will also correct, make it correct. So yeah, that is escape character. All right.
What is the reason that this part is different than what we saw before? Like this is formulaic to what we saw before. This is pretty much formulaic to what we saw before. This line here is different. Why is that? Because we're looking up a value.
Implementation detail. Yeah, we could have implemented the prior ones in the same way with a map. I just didn't. It only occurred to me to use a map when it became many, because otherwise I would have an escape or an extends tree.
Yeah, you would have nested extends and then okay.
Yeah, so it's just an optimization.
Type.cast s. Why do we need to cast s? Why can't we just pass in s here?
Because s is not a valid key for escaped character map.
Well, why don't we put that here then?
Then the type system, we'll need to say that it is types is that on line 131 instead of string. In the F in that cast.
Okay, let's do that.
And I suppose it worked. Yeah.
Wow. Okay. I'm gonna undo that though, just in case. I don't know. All the tests passed, so I mean, what harm could it really do? But Okay. Thank you for your patience on my.
No problem. That was a great question as well.
Okay. Then we're on to actual strings. So that stuff was just handling escaping in strings, but we haven't actually gotten to string yet. So this is string.
Yes.
Okay.
So yeah, let's start at the very top, right?
Mm-hmm.
Or like, yeah. So no. Let's actually start where you're like. Let's start at string parser. So we're saying what a string parser is it's something that is between double quotes. It's string contents that are between double quotes. So what we're kind of expressing this in like I suppose in a natural language sort of way. Between double quotes is something that will take in any parser and then surround that parser with double quotes. So if I had a foobar parser and I passed it into between double quotes, the parser that it returns would be a parser that parses, foobar surrounded by double quotes. So that's what between double quotes does.
Would you mind saying that again?
I will do better than say it again.
Okay, because I'm like, yeah. So, okay, yeah, let's see it. I love it.
Yeah, so do.literal foobar. So this is my foobar parser. It could be any sort of parser, but this is a really simple one. And then I'll say double quote foobar parser is between double quotes foobar parser. So now if I actually run type results equals parser. I don't know what I did. Oh yeah, okay, cool. Input foobar, we can put in first.
It'll still be never because it's not between double quotes.
Exactly.
Right?
Yes.
Okay, but if we put single quotes wrapping it so that it is between double quotes, then we get foobar.
Result. Yeah, I was confused.
Okay. Yeah.
Yeah.
But we don't get a string containing the double quotes. We just get foobar.
Yeah, exactly. So one thing that between double quotes does is it gets rid of the double quotes. Like we don't need them.
Show me that. Where is that part where it gets rid of it?
That is inside of between. Parser2.between, which is a built-in utility. So parser2.between is a utility that takes in a left parser,
line 145. Right parser. Okay.
Yeah. So between takes in a left parser, then a right parser, then a middle parser, and then it only returns the result of the middle parser.
Okay. The left parser is double quotes, the right parser is double quotes, and the middle one is string contents.
Exactly.
Okay.
Yes.
So I think something that threw me is I would expect you to be able to. So I would expect you to be able to pass. I mean, they're curried, obviously, so that's great, and the data is last, also great. It looks like all of these combinators are unary.
Yes, all of the combinators are unary. Yes. So that makes it hard. The ergonomics are poor because of that. In that you need to use the apply operator constantly to pass in multiple arguments.
I guess that's nice in a way though, because it keeps you from getting lost in the otherwise it would need to check for did you pass enough arguments? I guess there's no way to auto curry, there's no way to accept either.
So there is actually utility to do this, which is I'll show you real quick. I don't use it very often myself because I've gotten used to this form of reading it, but
yeah, let's rewrite this one with it.
Yeah.
Oops.
Oh yeah. I guess I'll copy it.
Whoa.
And then so now all good. So you use actually two dollar signs, and you pass in a tuple of the arguments that you want to pass in.
Oh, interesting. You don't just pass the second one. It has to be wrapped in a tuple.
It has to be wrapped in a tuple. And it's actually, let me see here. Oh, this is actually,
It's 3.
It's 3. It's $3.
And you have a $3 thing?
No. Okay, so I misidentified the double dollar sign versus a different one. This is $N. Sorry. Like I said, I don't use this very often, but if we use $N, that is a utility which does what we're mentioning. So it can make it a little bit more readable.
Yeah, because we could also, like, if we wanted to, we could also put string contents up here and then like just get rid of it from here, right?
Let's see. Yeah, we could totally do that. It breaks the little examples I have below, but yeah, it's equivalent.
Yeah, I mean, the test still passed for the JSON parser.
Yeah, exactly. So yeah.
Okay. All right.
Yeah, you can,
that's like a pipe then, almost.
Yep.
Interesting.
It is like it's a reduction. It's using like a reducer internally.
Okay.
Yeah. So yeah,
we're back.
Yeah, we're back. So let's actually talk about what string contents is. So
okay.
The contents of a string are many 0 or more string characters. So many is a parser combinator that takes in a parser and matches 0 or more instances of that parser. So string contents is just many string characters. And then a string character is just either an escaped character or any character except a double quote.
An unescaped double quote.
Yes.
Okay. And that's important because we're using double quote parsers on both sides of our middle guy.
Mm-hmm. Yeah.
Of our map.
Yes. And then, so what we're mapping, so when we finally parse that, we're mapping the result using string.FromList, which just joins a list into one string. So we can see this is a radically different approach to this problem.
I'll say.
Yeah.
What is FromList?
So FromList is just string.join essentially. So we're just taking in a
string from a list. Okay.
Yeah. I don't mind demonstrating it. So result to string.FromList, X, Y, Z, right? And we get X, Y, Z at the end.
I see. It's like a join with no argument.
Exactly. There is a string.join, but it takes in a join thing.
Can I just, like, for fun, I want to make sure I understand the ergonomics. If I wanted to use that string.join, I know it's not correct for JSON parser or whatever. I would pass in, okay, like that's the basis of it. And then I would pass in a character here.
Yeah, that's totally correct.
Oh.
And then what you get, so now in the string parser, it puts in an A between everything else. So
well, actually, I really should have done that in our little example because that would have been better. Okay, let me try it again. So there, string dot join, and then let's put a dash or something between them. What did I screw up?
It's just waiting.
Oh, it's just waiting. Okay, and that works.
Yeah. So yeah.
Do you have string dot split?
Yes.
Okay, and then for here, I would pass in X, Y, Z. Oh my gosh.
It's pretty fun. Like,
this is cool. Yeah, I'm sure this is like the most basic way to use this, I know, but like.
Hey, yeah.
Wow.
I like it.
How did you make this? Okay.
Yeah.
All right.
We'll make a video on it.
Yeah, no, I guess we will. Okay, array. Let's talk about array. Why does array look so simple?
Because fundamentally, it is actually kind of simple. No, that is a trope. None of this is simple.
No, yeah, but like
complicated.
it is not much. This is significantly less code than the other solutions to this problem that we've seen.
Yeah, so let's kind of talk about it. So one aspect of this array parser is that you can't see it, but it's taking in it takes in a parameter, which is the JSON parser. And the reason it does that is because I cannot reference the JSON parser directly in here, or we'll run into the same issue that we ran into before, in that the compiler will complain about a infinite.
But since it's curried, then like this is expecting a JSON parser. It just can't say that anywhere.
Exactly. Yeah. It's point-free programming. Point-free. So
that's something I have very few critiques of functional programming, but like that is one kerfuffle that I find problematic. Sometimes you make a pipe and the pipe is really wanting this certain thing to come in, but you can't really like, you have to kind of dance around the thing in order to say that like, hey, this pipe is designed to take in this sort of input, because the input is never named, so you can never give it a type, and then you run into this problem. But okay.
Yeah, this is a way to higher order. This allows you to create, type safe pipes on the value level, because that is what it's representing. But anyway, so what we're saying is we're taking whatever value we have, like whatever value parser, we're saying an array is a comma separated instance of those that is surrounded between square brackets.
Okay.
So we have a value parser.
Okay. Wait. Let's comma separated.
Yeah.
So you already wrote comma separated.
It's a utility, very simple utility. But what it does is it just says the input is like separated by comma. So we can test this out actually. And I can pass in my own value parser, right?
Wait, the dollar sign is a namespace too?
Oh no, sorry. I don't know what that's not
okay,
right.
Okay. I was gonna say what? How did you do that?
Yeah. Parser2.literal, and then I'll just say foobar, right? So now this is a parser that takes in a set of comma separated foobars and will return an array out of it. I don't have any. What is it? Okay, yeah, we're good.
Did TypeScript die? Wait, I'm not. Result is declared whenever used. Oh, this is correct. The type is supposed to be between T3.
Array parser. Oh, sorry. You
need to call it.
Yeah, of course. I need to call it. So type result. Why? Okay, what is failing though? Is there anything else that's failing in this?
No, nothing's failing.
Oh, at the top, there's there's
a red thing. Oh, all right.
We got it. All right, so now we can just say what the result is. So we can run my parser, and I'm going to say, foobar. And
but these are not comma separated anymore. These are these comma and space. Oh, but it would be space. Okay, fine.
Oh, yeah, comma separated. Sorry, I keep jumping around. My editor is weird. And then this just is expecting it
to be wrapped.
Yeah, wrapped in like that little state. Sorry, not like not like that.
The
sorry,
object.
I need a curly. I don't know what I'm. Yeah. Thank you. My keyboard is like strange. And then we need result never.
Input. Okay.
Yeah.
And then
Okay. And then we get the result at the end. Okay.
But it says never. TS language server crashed. Okay.
No, this should be fine. Yeah, if we. Okay, is the TypeScript server online right now?
I'm gonna restart it. Restart TS server. Let's see what we get. Okay. It says it's never.
Okay, let's see.
My parser is an array parser, but array parser is looking for the brackets. Doesn't it have to have this?
Oh yeah, it has to have the brackets. Okay, sorry. Yeah. You're totally right. I thought we were doing something.
It's all good.
Okay. So yeah, it only parses like foobar. And it
doesn't care about white space.
It doesn't care about white space. Yeah, and if I pass in like anything else, it will fail. So yeah, that's what array parser does.
Okay, so instead of making a literal parser, we did a string parser, did we? Or no, it's not a string parser. So what is the thing that's passed in place of this? Or it hasn't happened yet?
It hasn't happened yet.
Oh, okay. So later we're going to see a type for like JSON value.
Yeah, exactly. So yeah, and we can talk about BetweenSquareBrackets briefly. Okay. This is just saying we are, yeah, I mean, we're using parser.between, and then we're passing in a white space surrounded open, left square bracket, and then we're passing in a white space surrounded right square bracket. So white space surrounded is another parser combinator that just consumes white space around it. Yeah, which we could like build a example for, but
it's there in the library.
It's there in the library, yeah.
Okay.
So that's array parser.
Okay.
How are we feeling? Next.
I mean, I feel like I'm learning a new language, not in a bad way. Like it just feels like these are things that I'm like extraordinarily used to not even being able to be close to doing in the TypeScript type system.
Yeah, calling this TypeScript is almost a stretch. Like this is truly a new type system built on top of TypeScript.
Yeah, I think that's a great way to. Yeah, I mean, like, man, the things you could probably do with this. I mean,
yeah.
Whew. Okay.
Indeed.
You can't. You're not here in the room, but like my palms are a little sweaty, and it's like completely cool in my room right now. I have no reason to be sweaty, but it's just like, I don't know. It's exciting stuff.
Yeah. Indeed. Key value pair. This one is
this is a helper to object, just like string escape characters was a helper to string.
Yeah, it's a helper to object. So the first thing that key value pair is taking in is that JSON parser. So we take in that JSON parser,
but it's not named.
It's not named. Yeah, it's not named. And we're passing it through this pipe. So we take that JSON parser, and then we push.
Wait, hold on. Passing it through the pipe. So we could have just like called all of these just like a regular function calls. We could have nested the apply operator with all of these, but by using pipe, we can just sequence them.
We can sequence them.
Okay, and now we are speaking my language. This is like when I do stuff, when I don't have colleagues that are going to complain. If I have like a personal project, this is exactly what I do, is like write down the sequence of steps, and then each step gets its own little function, and then I pipe. Okay.
Yeah. You can pipe type function. You can pipe generics now. It's a paradigm shift. Okay. So we're taking that value parser, and we are pushing it onto the array string parser / key value separator. So what we want is a 3-tuple of a string parser, a key value separator, and then finally the value parser, because that's the sequence we want to parse. We want to parse a key, a colon, and a value, right?
What is push by?
Push by takes in a tuple, and then it takes in an element to push, and it returns that element put to the end of the tuple.
Okay, all right. Because we don't have that thing yet, because it's partially. We don't have it yet, so we need to. Okay, so this is like a placeholder insertion thing.
Yeah. So what sequence gets is the sequence that we're parsing is the key, the colon, and the value, and then we pipe that into parser2.sequence.
Where is the value? Can we just skip just for a second to where key value pair is called?
Yeah.
Where is the value parser defined?
That is the like JSON thing at the bottom.
Oh, okay. Never mind.
Okay.
Let's not skip ahead.
Sure. Yeah. So, and then we're saying, okay, that sequence can be surrounded by white space. So we're saying the key value pair, which is the key colon value, that thing can be surrounded by white space, which is true. Then we're saying, okay, that's the result. Now we're going to map it. And what we're mapping it to is this little, slightly complicated nest of logic. I'm using a type level splice operation. Splice from JavaScript.
Yeah.
So what I need to get is that the element at I need to get that so what I want is I don't want the key value separator is the thing. I don't want that colon in there. I just want to return a two-tuple of the key and the value. So what I'm doing is I'm splicing out the element at the first index 1 of the result.
Which is the key value part. This is the separator.
Which is the separator, exactly. So I'm removing the separator. All I'm doing is I'm removing the element at the index equal 1. And that's what this splice operation is doing. I should have a remove index, honestly, or like a delete index, but I don't have that utility yet because I haven't gotten around to it. It would be super easy to write, but splice worked for this case, so I used splice. Okay. Should I explain splice?
I mean, I actually am going to be courageous and say no. I mean, I think I understand what's going on. Splice is saying, I'm going to wait for my thing. When I get it, I want to take is it inclusive on both sides?
So this is actually, the second element is a length. So the first element is the index, and the second element is the length.
So I want to remove the second thing in the list and leave everything else alone. Yeah,
and replace it with with like no objects. Because I could pass in like, this would replace it with like X, because that's just how splice works. But I'm removing it. So yeah. So that's all it does. And we can be courageous.
Wait, that means what comes back from key value pair is still a 3-tuple.
No, it's a 2-tuple.
Well, you said you're replacing it with an empty array. So that wouldn't it be like...
Sorry, this is the sequence of things to replace it with. So
okay.
Because
we're not actually replacing it with... Okay. So we're replacing it with nothing.
Exactly.
Okay. Joining with an empty string.
Yes. And that is key value pair. So what we get out of key value pair is a 2-tuple of like the key and the value.
Mm-hmm.
All right. So moving on, we have between.
So key value pair is the first step here. Does that mean that we could have taken all of these things from key value pair and put them here?
Yes, all of it is.
Wow, that works.
Yeah, all of it is referentially transparent.
Wow, it's like super composable.
Yeah.
All right.
It is more verbose, but you do have that flexibility aspect. So we're taking that value, and then we're like value parser, and we're passing it into a key value pair. And then we're saying an object is a comma separated list of key value pairs, right? Which is true, surrounded by curly brackets.
Wow. This looks just like the code for between double quotes.
Yeah, and in fact, we could dry this because this is the beauty. And I want to actually dry this. Okay. This is the beauty of like this thing in that you can like use full dry. So we can create a higher level abstraction, which is
for all of this part.
Yeah, exactly. We can create a higher level abstraction whereby the concept we're representing.
Can I try to do it?
You can try.
You're so unconfident. Okay. All right. You have very little faith in my abilities. That's okay.
This one is actually, well, yeah, no, actually, yeah, we can do it. We can do it.
Is that a thing?
Yeah, you can do it. Yeah.
Okay, but T has to be
a string.
Okay. Yeah. Wow, that's interesting. It knows that it has to be a string. Is that because of white space surrounded?
No, because parser2.literal has to take in a string.
Oh, I would have thought it was like, I guess that would be primitive. I thought maybe null and friends would count. Okay. Is this what you were going to do?
No, but this is actually better and simpler than what I was going to do. So I'm glad you're doing it this way.
Okay, so thing. There. Actually, let's just not kill our spacing. Yeah, and that works.
And that works. And now you can create a further abstraction, which is passing. You can create like a between and then like left and right.
Yeah. Okay. So
and then really you just copy the implementation from between curly brackets.
Actually, I'll just grab this, and this is going to be L, and this is going to be R, and this is going to be so actually here we don't even need the helper type anymore. So we can just say this is going to be like this and this.
Exactly. And
cannot find name between okay, TypeScript is just worried about that. I'm going to restart TypeScript again, but yeah. Wow.
Let's keep this and let's validate that it's actually.
It says language server crashed. Okay, is there a syntax error here somewhere?
Yeah, I think there's a syntax error. No extend string.
Yeah, it crashed again. Okay. Is it this one? No.
No, this looks right to me.
Okay, I'm gonna do my thing that I do to format this because it helps me find things like this, and it's very formulaic. Okay, that is not broken. Oh, we're missing are we missing one here? No. Okay.
No. Okay. So yeah, I think this might be just the compiler crashing. And this happens when you.
It's not crashing now, is it?
Oh, it's not crashing, is it? Not.
Let me restart it one more time just for good measure. Did I tell you that I found a TypeScript bug? I'm very
no, you didn't.
Proud of. Do you have infer in here? Oh my gosh, we're so many levels of remove that there's no infer. When you do x extends infer y or whatever, you cannot put the line break there, but you can put the line break there.
Oh, that's so strange.
You should be able to do both. And I mean, I think it kind of tracks. Anyway, it is a bug confirmed by Ryan Kavanaugh, the great.
Okay.
If you're watching Ryan, you're my favorite. Anyway, Ryan is the best. We all owe him a lot for his efforts. Yeah.
So I think it's legit crashing, and there's a reason why this happens.
Okay.
When you create higher order types using generics, the system doesn't like that. Is the statement. So you would have to write this as a higher order type such that you aren't passing in, such that you're passing in L and R as like legit bona fide.
Okay.
Like,
can we refactor what I did to be that?
Yeah.
That's actually kind of instructional actually, because what I did is I think the like caveman solution, what you would do if you didn't know any better. Yeah,
exactly. So let's do it. Oh, no. Sorry, I should. You say things like that. I should push back.
Yeah, no. I didn't mean for you to. It's just that you were so like, yeah, definitely. I love it. No, it's great. It's great. Take it well. Don't worry.
Okay, so I'm gonna rewrite thing first. And instead of thing, I'm going to think about what this is actually saying, which is, this is saying a literal thing surrounded by white space. So I'm going to call it like literal with white space.
Okay.
And there's no parameter, right? Like no T.
Yep.
And so everything is point free. So I can't actually talk about what I'm doing, but I can say, I do know, oh, we're passing it through parser2.literal. So what I can do is I can do kind.pipe, and I can say the sequence of things that I'm going to pipe it through. And the first thing I'm going to pipe it through is parser2.literal.
Okay. And the second thing you're going to pipe it to is white space surrounded.
Exactly. It's literally that simple. It's not this. None of this is simple. I
mean, that part, I think, yeah, it's okay. You don't have to feel simple is not a swear word. I was just giving you a hard time.
No, I mean, I really detest when people call things like this simple, because I think it is it makes a person who is like first learning this stuff very unhappy, because when I read super complicated stuff and they're like, this is trivial, I get enraged and demotivated. So
I have something similar. I have a good friend who's like pretty much the most talented engineer I know, and he'll use the phrase "of course" a lot. I'll say like, "Oh yeah, like something something Berkeley sockets something something." Be like, "Well, of course X," and I'm like, "Okay, well, it wasn't of course level to me." But
yes,
he means well.
Actually, so before we build this, can we just get the original BetweenCurlyBraces thing?
Yes, certainly.
Just so that the compiler will stop being upset.
BetweenCurlyBraces. Well, we did have this thing here. So let me grab that.
No, it was just between curly braces like that.
Brackets. Yeah.
Yeah. Okay.
Oh, they are. Now, you misspelled it. It's braces. Didn't we just decide in the last challenge?
We did decide.
Oh well.
Yeah. Unfortunately, before we decided, I was not able to make that retroactive decision. Okay. So everything is passing now. We're all Gucci, right?
I think so. Gucci. Yes.
Type system is not crashing.
It is for me. I'm going to restart it on my side. I mean, we're on live share, so yours might be working. Okay, mine is working. Everything is good. Everyone is happy.
Okay. Everything is good. So I'm going to paste this in.
Okay.
And I will, okay, so it's complaining, and it's complaining for a good reason. It's because I had a syntax error. All right.
You know, I was going to ask about that. It didn't make sense to me, so I'm glad we got that sorted. Okay.
Yeah. Okay, so this is the literal with white space parser that you had before, and now I'm going to write the between brackets, I'm going to say. And what this is going to take in, so I just say equals never because, you know, getting my bearings. So we have two options here. We can either pass it in as a two tuple, or we can curry it. I prefer currying it because I prefer all higher order types to be curried. Mm-hmm. So the first thing we're going to take in is the left and then the right. And then we're going to, that's all we'll take in. So,
okay.
Left is passed here. And all of this, we're passing it through all of this. So fundamentally what we're doing is we are piping it through literal with white space. So I'm going to begin with kind.pipe. And I'm going to say, sorry.
You did the same thing again. I'll fix it.
Yeah.
Yeah. Oh, well, either way.
You can fix it. Yeah.
I feel good about being able to do something. That's why I want to fix it. Okay.
Yes.
All right.
Okay. So, and I'm going to say literal with white space. We're taking in that left curly brace, and we are saying it is a literal string with, that is surrounded by white space. And now, the next thing is a little complicated. So we get from that a parser. What we are doing to that parser is we are applying all of this. So the way we represent that is with something called kind.apply.
Oh, is this the one we saw before?
Yeah, I think we've seen kind.apply before. It's a little oh, I jumped around.
Are you were following me? Okay, because I was looking. Key value pair had kind.apply. Yes,
it did.
Okay.
Yeah, and kind.apply is kind of like the opposite of $. So what we have now, so this isn't correct, first of all, but we're saying we're applying this parser to the one that we get from literal with whitespace. So now what we need to do is we need to kind of extract out the
parameters, the brackets.
The right bracket. We've already extracted out one bracket. We need to extract out the other bracket. So
wait, when did we extract out the first bracket?
We did that magically. Like that's it. None of this is set.
Because it hasn't been applied yet.
Yeah, exactly.
Okay.
It's like time travel with your brain.
Yeah. Okay. Yeah. Because when we call between brackets, okay, can we do this first? We're gonna between brackets. I mean, really, we're gonna make a type. Can we call this between?
Yeah, we can. We should call it between because we're not doing it.
So between. Okay. We're gonna say like this. Be between, and then it's gonna get
the left curly bracket. And this
left.
Should work. This should work on its own if I implemented things correctly. But maybe it doesn't.
Let's see what kind of error we get here. Oh, these errors are not.
Oh yeah, the errors are like beyond knowing.
Errors are not a fun time.
Yeah, it's
literal with white space. Then we're applying parse it to, and we have the right thing.
Yes. It could be that I'm not. That kind.apply is. Oh no! This is not what we should be doing. Okay. Having the other red is gonna bother me, so I'm gonna replace this with between curly brackets.
Well, just comment it because it's like helpful.
Yeah, and I will comment out the actual implementation we want.
Okay, I want to know like what we're aiming for because that's gonna help.
What we're aiming for is between this and then.
Yep.
Yeah, that's all we're aiming for.
Okay.
Because that way in the other implementation, we can just replace it with like square brackets.
Okay.
So we have, this, so we're passing this through parser.literal, and then, I see. Okay. Then we're passing it through whitespace surrounded, but then this needs to be applied to parser2.between. So what I'm going to do now is I'm going to pass in how do I want to do this? Kind.apply. And then, okay, I give up. This is too complicated.
Yeah, I mean, but parser2.between is waiting for, it's like all of these things are waiting for their last argument. And kind.apply is saying, I have it now, do it.
Yeah, it is. I need to be in like a certain state of mind to be able to do this combinator calculus.
Okay, it's okay.
What I will do is do the first thing that you did, which is I believe we replaced all of. So this is. Oh, okay. So yeah, I'll get rid of this, and then we can at least use literal.whitespace. So that's going to be
Literal with white space. Yeah.
So that should be fine. Question mark is not even. Oh, kind not applied doesn't need to be here. Okay, now what is? Okay, so this is valid, yeah. And then we can replace all of this with, this one.
Mm-hmm.
And then, we kind of get more similar to the structure, but I think it's best to stop here. The combinator calculus, when you have like multiple inputs and you need to put this input where it needs to go, it gets kind of tricky.
To anyone who's going to hate on our present failure, I mean, if you read about, so I'm not a Haskell professional or something, but when you get into functional programming stuff, very frequently you see big red flags, large warning signals, and like alarms and flares going off saying don't allow more than one thing. All unary is the way to go. It sucks because, it's a fact of life, as we see here. Sometimes there is more than one thing that you need to supply. So in those situations, you end up kind of cheating by returning a thing that's waiting for another thing to return the final thing.
I feel like so this does have a really simple solution, and I'm tempted not to give up. I just don't want this video to be infinitely
I do want to
long.
say we're already an hour, over an hour deep. Mike and I have been, it's a Saturday at 6:40 p.m. and Mike and I have been doing these challenges since 2:45. So factor that in, if you will. Okay, let's keep going. JSON. So I think I'm starting to get the hang of this, actually. But these look different. These JSON, these are helpers.
So this is a set of helpers, and it is a really, really unfortunate hack that I had to do to get this working because of the lack of. I haven't figured out how to do higher order type level recursion. So what this actually does is it just.
Oh, it does the first one.
It does the first one, and then it passes in itself as a parameter 7 times. So it we nest it up to 7 times. So unfortunately, we'll only be able to support up to 7 levels of indirection before it just gives up. Okay,
Gabriel Bernard. If you're listening, you will be listening. I'm going to send him this for sure. Please tell us how to do this, or if maybe he has. I'm sure he has faced it as well. That's interesting. That's a pretty serious. You haven't mentioned that until now. I feel tricked.
Limitation. Yeah,
that's a pretty serious limitation of all of this.
Yeah, it is. I am working on a way to fix it. I think there is a way to fix it. Notably, if you do tie the knot here and pass it within itself, there's a way you do it where the compiler will instantly crash. As soon as no matter what I do, as soon as I make a higher order type reference itself in the way I want, the compiler instantly crashes. There's some singularity that happens. It's very strange and bizarre, but anyway. That hack aside, what we're saying, so all of this is just saying, a JSON is either a Boolean, null, string, or it's an array or an object.
Can I stop you just for 1 second?
Sure.
You can't see my screen, but I'm going to switch my screen. I'm going to send you a link. This problem that Mike is talking about is a problem that exists in a lot of versions of ways to do functional programming. And I can't help but mention, so years ago, so this is Ramda. Did you get the link?
Okay. Oh, Ramda. Yeah, I'm familiar with Ramda.
So once upon a time, before Go, I used to, oh, my kubectl thing is not up. Okay, anyway, it doesn't matter. I used to work in Go a lot. And I really wanted to do functional programming in Go. Some of you may be snickering because you know that that's a terrible idea. Well, I was convinced it was an okay idea if only someone would make a library to support it. So what I did is I started translating Ramda into Go. and I was very excited about this project, and I thought that it had real potential. The problem I hit was there is one sneaky thing hidden very deep within the Ramda. I think it's very deep within the Ramda code base that people may not know about, which is that it has auto currying, but only up to 10 parameters. Womp womp.
Womp womp. Yeah.
And,
yeah.
you know, basically to do what's on the screen here requires dynamic programming in some capacity. And Go is not a dynamic language. So this ended up, I mean, I spent a long time. I didn't have ChatGPT back then, so maybe there is a way I could have asked someone, but like every Go expert that I asked about this, I would have to like dance around what I was really trying to do. And finally they'd ask like, what are you actually trying to do? And I would tell them and it'd be like, oh, of course you shouldn't do that. And I was like, okay, I know I shouldn't do that, but how do I do it? But I just thought it was too prescient to not mention that like, we're just talking about arity. So arity is the term for how many arguments a function takes. Like a unary function is a function that takes one argument. A binary function is a function that takes two arguments. A what's it called when there's nullary means it has no arguments, so forth. So anyway, I just thought this was was like an interesting sidebar. Maybe good to have these sidebars in a long video like this. But okay.
I would like to write what I want the implementation to be and
Please.
what I expected the implementation to be.
Okay.
Which is JSON, like I said before, is either, right? It's we have a choice, so it's any of these parsers that I will say, and it is either a Boolean parser, or it's a null parser, or it is a
string parser,
or it is really I would like to just say array parser, but with the current array parser requires a parameter, so I would like to say, okay, it takes in JSON, right?
Mm-hmm.
And then object parser takes in JSON as well. So this should work. Like I should be able to do something like this, but no matter what I've tried, I haven't been able to get it to not complain about circular reference or instantly crash.
Mm-hmm.
Yeah, and I think if I was able to get to this implementation, I would be very, very happy with this JSON parser. But I have to do the unfortunate hack of passing all the above is essentially doing is I'm copying all of this and like pasting it in here and then removing these two. It is like fundamentally what's going on, which would work up to like a certain level of depth. But instead of doing all that, I just
made your helpers,
made my helper that does that on my behalf essentially.
Okay, so nest.json. Okay, so the first one, I got it. Okay, so the JSON helper is the first one, and then nest.json is for every subsequent run.
Yeah. So yeah, that is, and that's JSON parsing with higher order using parser combinators.
Wow. I feel like my life is a lie. Like I've been living a lie. And there was this other, it's like you're in a time travel movie and you travel through time and you find out that there was a universe where you like, I don't know, hit the lottery. It feels very enlightening, but also I don't have a time machine. So I feel like it's out of reach almost. Like this. It's definitely good food for thought for when we talk about HKT. So for everyone to know, Mike and I are planning to sit down and make a video showcasing hkt-toolbelt directly. What we're going to try to do, Gabriel said that he was down. So Gabriel Vennard, the author of HotScript, HotScript is extremely similar. I'm positive we could implement this same type of thing in HotScript. In fact, that might be a fun thing to do someday. And so what we're going to do is look through hkt-toolbelt with Gabriel, and also Mike and I and Gabriel will look through HotScript. So we'll make two videos. And we'll definitely talk about all of these topics and go through all this stuff. But hey, maybe I'll tell people to take a look through this video I don't think this is a primer on, we touched the things we had to touch, but this is just so, I have so many interview type questions I want to ask you about, like what inspired you to make this, all those kinds of things, how you use it at work and all those things. But I'll save those questions for when we do that video. It's a very interesting topic. Mike, I couldn't have done this without you. I believe really, truly, it would have been so hard to do this series without you because you've added so much value. And it says a lot to me that the users, I'm a software engineer. All I think about is people in terms of users, that viewers are so positive, like they respond so positively to you and what you say and how you explain things and how patient you are. And they don't complain much about how stupid I am trying to look through these things. So I appreciate that. I just want to say a big thank you to you. It's been an extremely wild ride to get all this. I really wasn't sure if it was possible to do, 140 videos, every day from January 1st to May 20th. And we did it. It happened. So thanks for everything. And, I'm gonna need a nap after this.
Oh yeah.
That's it, I guess. On to greener pastures with new kinds of videos and new kinds of things. So I'm sure people will be seeing you on the channel. We've already talked about a couple TypeScript theory crafting videos. We're gonna transition to making more very focal, small 3-minute, 5-minute videos about like a very specific topic about like how to do recursion or basic stuff like what is the infer keyword? I don't know, stuff like that. Much more interesting actually than those two, but I don't want to give them away. So, all right, that's it. Bye everyone. Bye Mike. Thanks again.
Bye.